and warm welcome everyone. I'm Akriti and with me I have Divya. Today we are talking about trustworthy AI governance and how organizations can set up frontier COE to scale AI safely, responsibly, and with confidence. As AI moves from pilots to production, the question is not can we build AI? The question now is can we trust it, secure it, scale it, and keep a uniform tab on the quality of agents and make a repeatable pattern across enterprise. We will connect governance, security, responsive AI, and center of excellence into one practical operating model. The goal is to help leaders move from experimentation to enterprise value without creating unmanaged risk. We will paint a holistic picture as we cover AI pillars of organization and frontier COE setup, governance setup, operating model, governance layers, tools, and next step. Think of it as a journey from awareness to execution. So let's embark on this journey. We start with why governance matters, then we move into how strong governance works, and finish with practical tools and actions. Now, before we discuss frameworks, let us ground the conversation in why governance has become so important. Organizations don't fail because they lack AI tools. They fail because they lack connected systems. AI success depends on multiple pillars working together in an integrated system. Governance is the connective tissue that holds these pillars accountable. Without the connective layer, progress becomes fragmented, accountability weakens, and AI never truly scales. AI success is not about chasing isolated pilots or individual tools. There are 5 drivers of AI value: business strategy and experience, technology and data foundations, governance and security, organizations and culture, and AI strategy and experience. No organization matures evenly across these drivers. One area often advances faster than the other, and imbalance creates friction. Weak data foundations can make scaling difficult, weak governance erodes trust, weak culture slows adoption. Frontier transformation is a system level outcome. Governance helps leaders see dependencies instead of optimizing one driver in isolation. Now, this gives us a system view. Divya, can you help let us look at what changes when AI becomes more generative and agentic and the new risks that come into the system with it?
Generative AI introduces several categories of risk. First, application quality, ungrounded outputs, errors, and hallucinations. Second, adversarial risks such as jailbreaks and prompt injection, including hidden instructions embedded in documents or other data sources. Third, harmful content, unsafe imagery, or insecure code generation. And finally, human-like behavior. When does a system become misleading, inappropriate, or manipulative? These are not edge cases. They are expected behaviors unless strong controls are built in. Building on these risks, the complexity increases further when we move to agents. Agents amplify these concerns because they move the risk profile from isolated tools to systemic exposure. As agents scale, ownership can become unclear and permission can become too broad. That creates agent sprawl and resources access risk. Agents also move across systems, users, and data sources, which increases oversharing and leakage risk. New AI-specific threats, such as indirect prompt injection, do not fit neatly into traditional application security models. And regulatory pressure is increasing while organizations are still defining what compliance looks like in an agent-driven world. This is why AI needs intentional governance, not just ad hoc controls. So the key question becomes, what does it really mean to trust these systems? Trust in an AI agent means enforceable control. An agent is trustworthy when it cannot be easily misused or jailbroken, when its actions are logged and traceable, and when it operates with clear data boundaries. Trust also means generated content can be governed, reviewed, and audited. It means the agent does not produce biased or unethical responses and does not misuse connected tools. These are not premium features. They are becoming baseline regulatory expectations. Trust is not something we add later, it is something we design it from the start. But trust alone is not enough. We also need to balance it with speed and innovation. Different roles optimize for different outcomes. Builders want speed, usefulness, flexibility, and efficiency. Security leaders, on the other hand, focus on protecting sensitive data, discovering agents, controlling access, and staying compliant. CIOs care about consistency, visibility, review processes, cost efficiency, and the most important, return on investments. Now, governance exists to reconcile these pressures, not to choose one side over another. The goal is not to slow down innovation. The goal is to create shared guardrails so innovation can move without creating unmanaged risk. That is the balance that we are trying to strike. Now I'm going to hand over to Akriti to walk us through Frontier Center of Excellence.
Well, the Center of Excellence becomes critical here because it provides the operating model that connects strategy, governance, and execution. The Frontier Center of Excellence is a coordinated approach across business and technology to deliver rapid, scalable, and sustainable value through AI. It's built on 4 pillars: governance and strategy, technical capability, skilling, and business alignment. The governance pillar creates cross-business ownership and accountability. The technical pillar standardizes architectures for efficient production deployment. Skilling democratizes AI knowledge across organization. Business alignment prioritizes the highest impact use cases and creates a maturity roadmap. This turns AI from a collection of one-off projects and POCs into repeatable enterprise capability. When a COE is implemented well, the benefits are tangible. Organizations gain a mature AI strategy at scale, consistency in tools and operational approaches such as MLOps, and a roadmap of high-impact business use cases. They improve the AI skills and capability across their organization, and they strengthen responsible AI tooling and governance. These outcomes are much harder to achieve through isolated efforts. The COE aligns initiatives to broaden business objectives and turns AI into a strategic capability. A center of excellence helps organizations move quickly while staying compliant and aligned to their strategy. It accelerates the intake and enables compliant AI experiences tied to corporate priorities and requirements. It helps leaders determine their posture for generative AI adoption, establishes the infrastructure for practical communication and access to AI, and supports upskilling of key roles. AI readiness is not just about technology, it's about the right team and operating mechanism to make practical adoption, compliance, and sustainability. Divya, the next piece is how that becomes a governance framework with clear ownership and decision rights. Divya, can you walk us through, please?
Thank you, Akriti. This framework shows how governance operates across levels of organization. At the executive layer, leaders set the vision, make strategic investment decisions, and provide sign-off where needed. Senior leadership then translates that vision into priorities, partnerships, and major build versus buy decisions, while resolving blockers and risks. The AI program governance layer keeps standards, safety, architecture, and responsible AI aligned across initiatives. And the work teams execute day to day, designing, building, scaling, and driving AI diffusion and skill development. This structure matters because it clarifies who decides, who reviews, and who delivers. There are three common operating models for AI initiatives: hub and spoke, centralized, and decentralized. The hub and spoke model balances specialization and community, but coordination can be complex and the size of the central team is often underestimated. Centralized models create strong control and reusability, but can distance AI experts from the business and slow time to value. The decentralized models create strong domain specialization and faster local value, but often lead to silos, duplicated tooling, limited visibility, and a higher cost. Every model has a trade off. Governance helps balance agility, consistency, reuse, and control based on maturity. The model gives structure, but maturity takes time. Let us move into what governance journey looks like as an organization scale. Over to you, Akriti.
Thank you, Divya. Governance is a journey and not a one time project. As AI capability grows, governance must mature with it. Strong governance develops through deliberate milestones rather than appearing all at once. This section helps leaders understand what good looks like for an organization moving from informal controls to trustable, auditable AI. The roadmap gives us a shared way to think about how governance and security evolve as AI scales. There are 5 different maturity levels listed here. Most organizations don't sit neatly in one stage. It's common to see experimentation in some areas, basic guidelines in others, and more mature governance where risk is already high. The important shift happens when governance moves from informal controls to integrated operational discipline embedded into your life cycle. Governance maturity usually shows up first in visibility, consistency, and accountability. It scales only when the right enablers are in place. Responsible AI principles, governance mechanisms, security and risk controls, and privacy foundations. Now, to make the roadmap actionable, let us start with the first enabler. Divya, this is where responsible AI principles and readiness comes in. Could you please walk us through it?
Absolutely, Akriti. So let's walk us through the responsible AI framework and principles. Some questions surface whether responsible AI is clearly defined, owned, and applied in practice. The issue in many organizations is not intent, it is inconsistency. Different teams interpret responsibility differently. Risks surface late, and compliance becomes harder to demonstrate. What works better is a clear responsible AI framework, a cross functional council that applies it consistently, executive sponsorship that reinforces it, and teams that use the principles before deployment. This is about clarity and consistency, not policy volume. At Microsoft, we anchor responsible AI in 6 enduring principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. Fairness is about equitable outcomes. Reliability and safety are about dependable behavior. Privacy and security protect information and systems. Inclusiveness ensures systems are designed for people with different abilities and experiences. Transparency and accountability ensure people understand system limits and that human oversight remains clear. These principles define expectations before tools or use cases. They remain durable even as the technology evolves. This slide shows how responsible AI governance becomes operational day to day. On one side, we have businesses' demand coming from teams trying to solve problems or improve how they work. On the other side, technical, data, and security teams supply the execution capability. The Responsible AI Committee sits between these two worlds with clear decision rights, a charter, defined review criteria, and explicit outcomes like approve, ask for changes, or stop work that creates unacceptable risk. The feedback loop is crucial because it prevents late stage surprises and reduces rework. When done well, governance becomes a facilitator, not bureaucracy. Responsible AI is not a one time policy or a technical checkbox. It is an operating discipline. It starts with principles and embeds them in the center of excellence. Then those principles become governance standards and impact assessments. Organizations then add red teaming, continuous measure and mitigate cycles, and always on production monitoring. Trust is built through repeatable practice, not intent. The message is consistent. Customers' data remain customers' data, control, protect data and models throughout the life cycle, and safety systems are built in so teams can move with confidence. These questions test whether governance is operating as a coherent, scalable system rather than a set of isolated controls. As AI systems become layered across models, prompts, data, agents, and integrations, governance only works if controls are applied consistently. If controls vary by environment or team, the result is shadow agents, inconsistent behavior, and actions that cannot be traced. Automation is another signal. Manual reviews cannot keep pace with AI development. Lifecycle governance matters too, because without approval, registration, and retirement processes, risk accumulates quietly over time. This slide gives teams a practical landing point for operationalizing responsible AI. The lifecycle is simple: map, measure, mitigate, operate, and manage. Teams can start with risk assessment templates, responsible AI guidance, red teaming practices, and tools like Pirate. They can then evaluate applications in Azure AI Foundry and manage risks with model catalog choices, content safety, safety system messages, RAG patterns, continuous monitoring, and security posture tooling. The key point is that many capabilities are already embedded into enterprise platforms such as Azure AI Foundry, so organizations do not start from zero. Agent governance ensures agents are secure, compliant, reusable, and aligned with business priorities. Without governance, agents can become a new form of shadow IT, duplicated, over-permissioned, and hard to audit. With governance, agents become enterprise assets, registered, reviewed, reusable, monitored, and aligned to responsible AI expectations. It creates lifecycle discipline from ideation through deployment and monitoring. It also brings engineering, security, compliance, and business teams into one shared framework. Done well, agent governance is not restrictive. It enables confident innovation by removing ambiguity and rework. If AI agents are becoming enterprise assets, security has to evolve with them. This brings us to the changing threat map for agentic AI that Akriti is going to walk us through.
As AI becomes more agentic, the threat landscape changes in important ways. Some risks are familiar, such as shadow AI and sensitive data disclosure, but agents introduce new threats tied to autonomy and action taking. Three areas matter most early on. First, intent breaking and misbehavior, where agents stray from their intended purpose. Second, tool misuse and exploitation, where connected systems or data are abused. Third, memory or context poisoning, where malicious instructions are embedded over time These are not problems security can solve alone. IT developers and security all share responsibility. Observability is foundational for trust. Everything starts with observability because you can't govern or secure what you can't see. But observability isn't just about visibility. It is the control plane for trusted AI operations. IT teams need a centralized inventory of what agents exist, who owns them, and how they operate. Developers need real time insights into how agents behave in real conditions so they can improve quality, safety, and reliability. Security teams need unified detection across agents, data, identities, tools, and threats. Without this, organizations face shadow agents and untracked actions, inconsistent controls, and audit gaps. With shared security primitives, inventory, access policies, data protection, and threat detection, observability becomes the foundation of how governance can scale. AI security has to span every layer just as the risks are spanned across the layer as we see. This includes data security and compliance, threat protection and posture management, identity and access, and AI governance and safety systems. These controls must apply consistently across copilots, agents, AI apps, and the platforms and the clouds underneath them. The point here is coverage and cohesiveness. Governance and security work best when they are integrated into one connected foundation rather than layered inconsistently across. Once agents are treated as first class identities, the existing identity model naturally extends just like it does to individuals in the organization to the agents as well. Teams need to manage agent identities and lifecycle, govern who can create and manage agents, govern permissions, and protect access to apps, tools, systems, data, and other agents. The same discipline that protects users becomes the foundation for protecting agents as active enterprise actors. It's not about reinventing identity, it's about extending the identity governance to a new class of participants in your enterprise workflow. Agents based attacks do not look like traditional security incidents. Agents have memory, autonomy, and tool access, which changes both the attack surface and the techniques adversaries use. SOC protections therefore need to evolve to include real time prompt injection blocking, agent security posture management, emerging threat detection, and hunting across agent specific telemetry and data. The job to be done remains familiar: investigate, respond, hunt, and improve posture. But the telemetry and control needs to evolve for agents as new class of actors. This loop enforces the code to runtime mindset. Developers are moving quickly, creating AI applications and agents. Security teams are focused on posture, compliance, identity, data protection, and threat management. If these two groups operate as separate handoff points, security falls behind the pace of innovation. The better model is integration. Content safety, red teaming, secure development workflows, identity, posture, data protection, and runtime protection all connected together. This is what allows teams to start secure and stay secure. Now, this enforces why security cannot sit with one team alone. The next question is how privacy and compliance keeps pace as agents become more active in enterprise workflows. Divya, can you walk us through, please?
The answer to that question, Akriti, is data privacy and compliance. This set of questions checks whether privacy and compliance are keeping pace with AI and agentic workloads. AI amplifies existing privacy risks because data flows become more dynamic and less predictable. Organizations need rigorous privacy controls, formal security and compliance assessments, ongoing legal and compliance involvement, and continuous monitoring for drift and anomalies. The key message is that compliance cannot be bolted on at the end. It has to be designed into the lifecycle and maintained over time. As Gen AI applications become more common, a few data risks questions appear quickly. Who is using Gen AI? And how is access governed? What kinds of applications are in use? What sensitive data is flowing into them? And are outputs protected as well as inputs? Risks increases as adoption spreads beyond central IT, so visibility into users, applications, and data flow becomes foundational. With agents, the data risk profile changes again. Data access is no longer always triggered by a user. Agents can initiate interactions, move across systems, and operate continuously. When governance and compliance processes are fragmented, accountability becomes much harder. Without visibility into what agents are accessing, generating, and sharing, it is difficult to enforce policy or demonstrate compliance. That is why data security controls must evolve to treat agents as active participants in data flows. Agents are moving fast, and that speed is where data risk shows up. The most reliable place to apply protection is at the data layer itself. That means classifying and labeling data in agent workflows, governing what each agent can access, enforcing data loss policies, and policy controls automatically, preventing oversharing, and detecting risky data flows. The goal is not to slow agents down. It is to preserve productivity while reducing the chances of unintended exposure. AI regulations are emerging. They no longer are a future issue or a single region issue. The names differ, but the expectations are converging around governance, risk management, transparency, and accountability. The challenge for organizations is not tracking every regulation independently. It is creating adaptable governance models that can evolve with regional requirements. Global standards such as ISO 42001 and ISO 23894 provide useful reference points for that work. The shift here is not just the number of regulations, it is the nature of regulatory expectation. Across more than 90 countries, cyber and AI regulations are expanding, and expectations are moving from periodic reporting to real-time accountability. Organizations now need to show how systems are governed, monitored, and controlled as they operate. That raises the bar, but also creates a strategic opportunity. Resilience and trust become competitive differentiators. Trust becomes the control plane for resilient innovation. As accountability becomes more real time, the life cycle becomes the natural place for control. Akriti is going to walk us through how compliance and safety checks are embedded into that life cycle.
Trust holds up over time only when governance and safety are embedded across the life cycle. As agents are developed, tested, deployed, maintained, monitored, and scaled, compliance and safety checks need to travel with them. This means thinking about risk in development, validating behavior before deployment, and continuing to monitor as agents evolve. Governance is life cycle based rather than point in time. Teams do not have to choose between speed and safety. Governance operating model is where strategy meets execution. A governance operating model ensures policy is consistently applied, roles are clear, and decision making is streamlined. We are able to establish repeatable operating behavior across organizations. A strong operating model turns governance from documentation into day-to-day discipline. This is where governance becomes real. Every AI use case should move through the same discipline flow. Entry through an impact assessment form, risk assessment, triage, platform decision, build or buy decision, common compliance checks, uniform evaluation, red teaming, deployment, and monitoring. Risk triage helps us determine if there is any prohibited use of AI or sensitive use of AI. It helps us to categorize use cases as low, medium, high risk, which helps us then make informed choices across SaaS, PaaS, or IaaS platforms and whether any additional legal compliance or security review is needed. The aim is not to create friction, it is to create a uniform path to trustworthy production. This turns AI from experimentation and POC into repeatable enterprise grade capability. Let's bring together two things: cloud adoption framework phases and Microsoft's responsible AI standard. The cloud adoption framework gives the operating model, that's strategy, plan, ready, adopt, govern, and manage. The responsible AI standard provides the principles. Together, they create a practical and principled approach to create trusted, compliant, enterprise scale AI. When designing governance, you have to think in layers rather than one monolithic control set. Different layers address different kinds of risks: infrastructure, deployment policy, model behavior, operations, compliance, costs, security, and data. This layered view helps leaders decide where to invest based on maturity and risk exposure. It also helps assign clear ownership across every layer to have accountable people, process, and technology behind it. Here, we consolidate the major governance layers to keep track of. They include policy control deployments, model governance, cost management, security, operations, regulatory compliance, and data. Examples range from Azure policy and model inventory to quotas, defender protection, lifecycle management, purview compliance assessment, and data classification. The point is not to memorize every control. The point is to recognize strong governance is multi-layered and needs deliberate coverage across the stack. We have now defined the governance layers. The next step is turning these layers into practical tools, controls, and evidence that the team can actually use. Divya, could you please walk us through them?
Absolutely, Akriti. Now, let's look at the tools that bring governance to life. Policies and frameworks matter, but tooling is what turns them into enforceable and repeatable controls. This section focuses on practical tools that support governance layers at scale. The goal is to move from guidance to measurable control, evidence, and operational visibility. Let us now look at how these tools come together to support governance in practice. Now we shift from governance design to implementation. This is where tools make governance enforceable at scale. These services are API management, Defender, Entra, and Microsoft Purview. These services form the enforcement layer for governance across APIs, identity, security, and data. This view helps leaders think about governance maturity in practice. Organizations rarely sit in a single clean stage. The important signal is where tension begins to appear, especially when pilots start to scale and informal controls stop holding up. Tools and services matter because they improve visibility, consistency, and accountability. These are usually the first signs of real governance maturity. Services like API management, Purview, Defender, Entra, and Foundry provide the practical enforcement layers that make governance scalable. But governance is not one size fits all. It needs to adapt to different personas. Persona-based governance acknowledges that different roles experience governance differently. Teams do not all need the same view, but they do need connected views that reinforce one another. Builders need development and quality signals. Security team needs risk, threat, identity, and data views. IT team needs inventory, life cycle, and access controls. And executives need maturity, value, and assurance. The maturity discussion still applies here. Visibility, consistency, and accountability help governance feel enabling rather than friction heavy across personas. And underpinning all of this is observability, connecting every role through shared visibility. Now, let's look at how observability is delivered differently for IT teams, builders, and security teams, while still relying on the shared security primitives. IT teams get control plane for all agents. Builders get protection and control through the Foundry control plane. Security teams get a unified view across apps, agents, MCPs, data identities, and threats. Underneath that, Entra, Defender, and Purview provides the core primitives: inventory, conditional access, data policies, threat detection, posture, and compliance reporting. This is what makes observability work for every role without fragmenting the underlying control model.
Now that we've covered all aspects, let's start putting things together for next steps. So we learned today that AI governance and security are not owned by a single function. For the CIO, the lens is managed governance, visibility, control, and management at scale. For operations leader, it's managed operations, reliability, observability, lifecycle, and availability. For AI leaders, it's managed transformation, adoption, usage, value, billing, guardrails, and upskilling. For the CISO, it's managed security posture, threat protection, data protection, identity, and compliance. Governance connects all of these perspectives into one coordinated operating model. The COE is an amalgamation of all of these roles to create a coordinated effort across the organization for uniform adoption. This cheat sheet combines the AI governance maturity journey, core actions, and resources available to go deeper. It shows what organizations should focus on across different enablers and the journey to move from informal or no formal governance to trusted and auditable AI. Divya, let us now bring everything together into a simple end-to-end execution flow.
The end-to-end implementation flow is simple and useful. First, assess the organization's needs, goals, and current AI maturity level. Second, set up policies, processes, and tools for uniform AI governance and compliance checks. Third, create a prioritized roadmap to accelerate the AI journey. And fourth, partner and execute to move from planning into delivery. To summarize, governance is not a blocker. It is an enabler of scalable AI. The organizations that lead AI are not the ones that move without controls. In fact, they are the ones that build trust, visibility, and resilience into the way they scale.
We hope this overview gives you a practical path for building trusted AI through governance, security, and a strong center of excellence. We look forward to working with you to make AI scalable, secure, and trustworthy. Thank you for joining us today.